So what we're doing is dividing polynomials. So we are going to review the steps of dividing just so that we can see where things are coming from. So we'll do just an easy, like, here's what you should know from 4th grade. So if I had, say, 15, and I'm going to divide that into, say, 4,323. Okay? What would we do?
Divide.
How many times could 15 go with 43?
Okay, good. And how many times?
2.
2 times. So I write a 2 right there. And then after I did, so we did the divide step. That's what you did by saying 2. And then what do we do now?
Subtract 30 from 43.
Oh, you multiply 15 times 2.
Okay, now we multiply. So we do 2 times 15 and get 30. And then we subtract, right?
Bring down your 2.
We get our 13 and then we bring down our 2. So next we bring down.
And then start your cycle.
Right. And how many times would 15 go into 132?
8.
8?
8. So
8, 8, 2.
I actually think you're right on the 8. And what's 8 times 15?
120.
Okay, we subtract.
123.
And we bring down. And, I mean, we use common sense. It's 8 again, right? So 120, subtract. And now, what we do with this 3 depends. If we're doing with decimals, right? If this were decimals, I would add a decimal point, bring it up, and I would add a 0 and bring down, right? And then I'd get a 2 right here and get 30, and gosh, that worked out pretty nice in decimals. Or, if we were not in decimals, we would do 288, remainder 3, right? We are going to approach our polynomial division like this. We're going to write remainders. Our polynomial division follows the same steps. So divide, multiply, subtract, bring down. The difference is, and I'm going to erase all this. We good?
No.
You know, we know how to subtract, hopefully.
You said the remainder was 3, but isn't it 2? Oh wait, never mind.
It is a 3. Look at the blue.
Yeah.
Thank you, Daniel. Okay, so let's get rid of this. Now let's actually try a polynomial one. For example,
Bless you.
let's say I have negative 3x plus 4 plus 9x squared, all of that divided by 1 plus 3x. So the first thing is, and I hope that you have started recognizing this, neither of these things, that should be in parentheses, is in order, right? So that's the first thing I'm going to do. The thing that's come first needs to go inside the house here, and the thing outside, the divisor, see divisor. This is the dividend. And the answer is called the quotient. I don't have the answer yet. But let's get these in order. So that's going to be the first thing. I'm not going to write that as an actual step. Just know that we need to write these in order. So this is 3x plus 1. And I'm going to write this in order. What order should it go in?
9x squared.
9x squared minus 3x plus 4.
Good job. Okay. Now, I'm going to follow the same things. But I hope you're seeing, wait a minute. How in the world do I divide this into this? And this will be the first step. I'm going to look, just like when we were dividing with that 15, you estimate with the first digit. I'm going to look at the first term. And I don't really care about that one. I am going to use it, but when I actually do the dividing step, I'm not going to use it. So I'm going to look at this first term, and I'm going to look at that first term and think, what do I multiply this by to get a 9x squared?
3x.
3x.
Yeah.
Awesome. Very good. All right, so I've just done the divide step. See, I've done divide. Now I'm on multiply. Well, just like with division, what do you think I multiply?
3x.
3x plus 9x squared.
3x plus 1 times 3x.
Yes, I multiplied this entire thing by that 3x. So we are going to use that one. So what's 3x times 3x?
9x squared.
Okay, so I don't want that there. So 9x squared. And then plus 3x. Okay? Now I've lined them up. They don't always line up exactly like, are those like terms? Are those like terms? The only one that you are guaranteed will be like is the first one, because that's what we're using for our estimate step. The second one might not line up, so you just put it where it should be. So what's our next step? We did our multiply step. Our next step is to
Yeah, minus
so yeah, you're jumping ahead, not bring down. I need to subtract. So how you do this is up to you. This is what I do. Parentheses, subtract, because I'm subtracting, and I need to remember that that minus applies to all of those, right? Okay, now that's how I do it. Here's what other students do. Here's what actually most students do. They do this multiply, and then they remember, what do I need to do next? They do boom, boom. They switch the signs. You can do that, I'm alright with that, but you need to keep track of your signs whichever way is going to make sense. A lot of times what I find is students lose a sign. Okay, so you need to be careful. Alright, so we subtract. Either way, we end up subtracting. The sign switch. What's negative 3 minus 3?
Negative 6x squared.
Negative 6x, not squared.
I know.
Okay, and then this should go away, right? 9 minus 9 is 0. If that doesn't go away, I've done it wrong. Now I'm at the step that we were saying before, bring down. Now, in some problems, you bring down one thing. Some problems you bring down all of it. I like bringing down all of it because you never know what things are going to line up. Alright, now we're on back to the beginning, right? Divide. What do I multiply 3x by to get negative 6?
2.
So negative 2. Okay? Now I'm going to take this negative 2, next step, multiply by that.
Negative 6x minus 2.
Yes. And now I subtract. So when I subtract, see, this will be positive, and this will be positive. So what's 4 plus 2?
6.
And then that should cancel. There is nothing left. So, remainder 6. And this is my answer.
Oh, so Mr. Kane, you don't change negative 6x plus 4 with the, you don't add that negative. So you wouldn't do negative 6x minus 4.
Just like with division, if I had 10 divide 6, 1, multiply, subtract. Did I change the sign on this 10?
No.
No. I
Okay.
changed the sign on that 6.
Okay, I see.
Okay, so it's the second thing. It's worked. It really does work just like long division from 4th grade. You just have a bunch of letters in there. Okay? Let's do another example. Sometimes, well, we'll do one that's like what we just
So
did.
you just stop there?
What do you mean stop? We got the
That's your
quotient,
answer.
right? We have the answer.
Oh,
We're
okay,
done
okay.
dividing. Once you have the answer, don't argue with it. You got the answer. Let's do this one. That's an A. Again, is this in the right order?
No.
No. Okay, so as we write our division,
Excuse me, I actually figured it out by myself.
you had to plug it in, didn't you?
It was plugged in.
Oh, I love picking on you.
You're so mean, King.
I
That's a
know.
courtesy law.
All right, put this in order. What do we get?
Negative 6. We
A
got
squared.
a squared minus 11a plus 9.
Okay, so when you're doing these in your work, make sure you leave room to actually do it. All right, what do I multiply this by?
2a.
Careful.
Well, negative 2a, sorry.
Negative 2a. What do we get?
Negative 6x squared. Plus 4.
Now, do you want to add parentheses in the minus sign, or do you want to change
Add
your sign?
parentheses.
Okay, so we'll do this. Now, when you do it this way, you need to remember this 4 is not positive anymore. What is it?
Negative.
Negative. You have to remember that because I'm subtracting. So, actually, in a different color, I'll just remind us, right? Minus, that would be a plus, right? Because a negative becomes plus. All right, what do we get? Negative 11 minus 4 is?
Negative 15.
a plus 9.
That goes away. And then, yes, we bring down the plus 9.
So does the 6 cancel?
Yeah.
Yes, because negative 6 plus 6, see the negative negatives and plus, that goes away. That should go away. If it doesn't, then there's an error. Okay?
Negative.
So the first one should always go away?
Yeah, each time. Yeah,
Okay.
just like in long division, that first thing needs to go away. So negative 5, I heard, so negative 5 times this, what do we get?
Negative
Negative
15A.
15A plus 2.
Good. And then we're going
Remainder
to
19.
subtract. So this 10 is going to become a
Negative.
negative, and this 15 is going to become a,
Positive.
okay? I'm kind of doing like a merging of the two styles.
Remainder -1.
So I get a negative 1. And yes, remainder negative 1. Now, as a note, I am not going to talk about this little note again. I hope not. But let's say I did 15 divided by 4. Let's do this division. What do we get? 3.
3.5.
And then this subtracts and we get 3. So remainder 3. Back when you did fractions, you had a different way to write that, right? You could say 3, so you get the same 3, and then you subtract, and then you write and 3/4, right? So I can do the same thing here. I would write it as negative 2a minus 5 plus negative 1 over 3a minus 2. This is the same as this, and your book alternates between which one it wants you to write. They mean the same thing. Okay? Remainder negative 1, see? Over that, just like this 3 over that 4. Same idea.
You would take either one
Can
though.
we do the remainder way if we want?
Yeah, the remainder way better.
Unless it specifically says otherwise.
What is the other way called? The way with
It says write your remainder as a fraction.
Ah,
Right, 'cause
Okay.
it's not gonna be like, not the remainder way.
Okay? Not the remainder way. Sometimes this happens. Let's say we have a box. And let's say the area of this box is 50 centimeters squared.
Just a rectangle or a
Or it's not a square.
Okay.
It's a box. So, box. And let's say this is 10. What's this?
Okay, I got you.
And Coleman has the answer.
I don't have the answer, but
it's 5.
It's 5. Okay, it's 5. How did you get that?
10 times 5. Well, you divided.
You divided.
You
Okay.
divided by 10.
The area of a box is base times height. The area is 50. We'll say the base is 10. What's the height? We divided both sides by 10. We got it by the operation of division. We divided. Okay? So hopefully that makes sense to you, right? Complete sense. We're good there. So what if we have our box, but of course for our awesome honor students especially, but everyone, this is fair game for everyone. Let's say the box has an area that is 6x squared
this is great.
minus, well, let's make it cubed. We haven't done cubed yet. 6x cubed minus 5x squared. Now let's just make it an x. Yeah, no x, no squared there. Minus the 3. So the area is, I'll rewrite it up here because I changed it like 5 times.
6 cubed minus 5x minus 3.
Okay, yes, this will be a good example. And let's say one of the sides, let's say this side is 2x minus 3. And I want to know, well, what's this side? Now, I'm not going to declare it as x because that doesn't make any sense. I want to know what it is. So just like with the area is 50 and the one side's 10, how did we get the answer?
Area equals base times height.
And we divided, right? So this area, yep, and you were right, Jacob, area equals base times height, and we divided. So if I want to know this side, I'm going to have to do a division, right?
Yes.
Okay, so I'm going to take this area and divide it by this side, and that will give me this remaining side. So, a long division. 6x cubed. Now, before we fill this in, and this is why I left out that x squared. Notice, we're missing which term?
X squared.
Which one?
The x squared term. That means,
Do you assume it?
that means it's 0x squared. It's gone. So I need to add that in. Plus 0x squared, I need it as a placeholder for my division. That's going to make sense in a minute. If I write the number 101, does that 0 have meaning?
No.
Yes.
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 It means I have 0 tens, right? If I don't write that 0 there, I'd have 11.
Oh, okay.
Okay, so I need the placeholder. Same thing here. I need a placeholder there to do my division. So then I fill in the rest. I have the x term.
So you basically
Minus
do the
3.
opposite of what I said. You don't just assume. Right.
Well, if it's not there, it's a 0.
Oh, okay.
Okay? And then I would, if I had missing terms for this, I would fill them in, but I don't have any missing terms. Now I can do my division. Alright, so I have more terms than we did before. What do I multiply this by?
3x cubed.
3x
Squared.
squared.
That's what I meant, I promise.
And then when we multiply, what do we get down here?
6x cubed.
Plus 9, minus 9x squared.
Okay, good. And I want to make sure I line these up. If they don't line up, that's okay. I just line it up where it should go, and I do my subtraction. So I do my subtraction, and this is going to be a negative, right? And this is going to be a positive.
So that would be 9x squared.
And this other thing cancels. Now I bring down. Now, you can bring them, it depends on the situation. You can bring them down one at a time, or you could bring it all down. It really makes no difference. If I had, say I had 3 terms right here, then I'd bring down 3, right?
Right.
It's possible, I can't go through every possibility. Sometimes there's a reason where you just bring down everything all the time, and that would be especially the case if like this 9x squared actually lined up with this 5, and not this x squared. Then I might want to bring everything down. Alright, now this is going to be kind of weird. What do I multiply 2 by to get a 9?
What would be 4x?
4.5.
4.5.
4.5 is what I'm hearing.
Yeah.
So 4.5, is that times 2? Could I write that as a fraction? Would it be 9/2?
Why wouldn't you just multiply it by 4?
Because 4 times 8, I need to get rid of this.
So would you do it by 4.5?
So 9/2 is what I'm telling you to write it as. 9/2 x. Because 9/2 times 2 is 9. So this was actually a terribly hard example.
You couldn't have made it a 3.
I could not have.
Shame.
It's looking like I miscopied the problem that the book had, which is why it's working out really weird. But that's okay. So 9/2. So I get 9x squared minus 27/2.
Short.
Top times top of our fraction, and then we subtract.
So you have, what is that?
So that cancels, and this
That
becomes a
becomes a
positive. So we can use our calculator to help us if we need it, but 27/2 minus 5, I need a common denominator, so 2, and that becomes a 10. So 17/2
Right.
x,
Right.
and this is a positive number. And then we bring down to minus 3. So what do I multiply this by? Well, I need a 17/2 here, so
8.5. 8. God bless you.
Thank you.
4 is 16. 17 over 2.
You need Jesus.
close.
17 over 2.
That's what I just said.
So 2 times something has to equal 17/2, right? So if I divide both sides by 2, that something is 17/4. So plus 17/4. So 17/4 times that gives me 17/2 x. And then that's going to be 3 times 17. What's 3 times 17?
51.
Is it 51?
Yes.
So minus 51/4. Subtract. Alright, so those cancel. What's negative 3 minus 51/4? I need a common denominator. So that's 4, 12. So what's negative 12 minus 51?
Negative 63.
So remainder negative 63 fourths.
Wow.
That was a really hard one. And that would be the length of that side.
This is why nobody likes your class.
Let's do...
Did you copy it wrong?
Yes, I did copy it wrong, which is why it came out really weird.
Okay.
It was supposed to be 3x minus 3.
Alright. Let's try these two divisions. I'm going to write them up. I want you to try to do them on your own. Stay a step ahead of me. So I will write slower than normal. Do these in your notes.
Hey, you always say straight ahead of me. I'll go slower and you never do.
Okay. There's that example.
Make sure you copy it right. It's way over there. I'll get it later.
Oh. That should be an X. That would be very hard to multiply and figure out. But that's a B and these are X's. That would be like
Is there a level of math
if we
like
play Hangman.
Is there a level of math like that?
That you could do it. You could get an answer, but it'll be very, very strange. So we are not good. You don't have to worry about that situation. Wow.
Okay.
Anyways.
Some crap that you put on the honors test.
It is.
Trick question.
Are you giving me ideas?
No.
Oh, okay. Just check it.
Okay, will the next honors test have
The boxes on it? Yes.
no word problems?
Oh yeah, absolutely. I know how much fun you have with word problems. All right. Any questions how to get these two answers?
I got the first one right, but you went too fast.
Okay. Well, you got the first one. Good.
Yeah.
All right. I'm going to do the last thing for your notes, and then we're going to do a bunch of practice. And this is actually, I saved the easy part for last. So this is easier. The following situation.
Jeez, kid.
Guys,
You didn't like me.
gentlemen, this situation is way easier than what we have been doing.
You need the card.
Okay, so I'm doing a division. How many terms is this?
One.
One. That is by far the easiest situation that you could have, where your divisor is only one term. You still do it the same way. I look at only my first term, and what will I multiply this 2x squared by to get 8x cubed? 4x. So I'm doing it the same way. I just have less terms to worry about. So don't freak out if that happens. Be glad, and then we subtract. we get 0. So we bring down a 4x squared.
So multiply by 2.
So plus 2, yep. So that gives me my 4x squared. I'm still following the same steps. It's just I don't have as many terms to worry about. I subtract, I get a 0. See 0? 0. And then I bring down a minus 12x. Now, I do have a missing term here, but if it's the last term, I don't have to worry about it as much. And then this actually does not divide into that without it being weird. So I'm going to go ahead and do that as my remainder.
So would you do it as a fraction, or you would just do?
Well, I'm getting there. So plus negative 12x over 2x squared. Can I simplify this by rules that we've already done?
Yes.
Yes. So I have 4x plus 2. That would be negative 6, right?
Yes. 6x.
Over. And then
X cancels, which leaves a x in your denominator.
x in the denominator. That's correct. Okay. So in this case, you would want to write your remainder as a fraction. Okay. Do you want to see one more where it works out like that?
Yes.
Okay. We'll do one more where it works out like that. Let you get that copy down. Those type are easier, except at the end where you have to write it as a fraction and use your rules of exponents. Yes.
Is there like a big trick for this?
Nope. We're doing it the way that you need to do it. All right. Last example, and then we're going to do practice.
But couldn't we avoid all this by putting them as fractions and just reducing it by that way?
Some of those you could do that. But you want to do the long division for the cases that are mostly in your book right now. We're going to need a placeholder.
E.
This is huge.
Huge.
And I will write the original up here. The original problem was this. Gentlemen, you done copying this down?
Oh gosh.
Okay, so this was the original problem, and notice I'm missing the x to the 4th term. This one I'm missing. So if I'm missing a term, I have to fill it in. So I have 0 x to the 4th. Alright, let's divide. What do I put here?
2x to the third.
Which means what goes here?
8x minus 5. And the 8x is
Cancel.
Okay, bring down. Which means how many goes here? Well, 0. So that doesn't matter. So bring down.
4x.
So plus, and we need a 4x, you said?
Yes.
That's correct. So 4x times 4x squared is 16x cubed. Subtract.
Negative 1.
0.
Yep. So 0.
Bring down the 4. Negative.
Bring down negative 4x squared. Yes, Emma?
So
Okay.
you wouldn't put a 0 there or anything, so you would put a 0x squared to the 0x to the 4th?
I could. It just goes away in the end.
Negative 1.
So negative 1, I heard? Yep.
Yeah.
And then we get to...
Then it's the remainder plus 2x. All that.
Okay, so once this exponent is higher than this exponent, that's when we know we're done. So we won't just write remainder 2x, we'll write plus 2x over 4x squared. And then we go ahead and reduce that. So our answer is going to be, and we don't need that 0x squared. I'm getting there, hold on. And then 2 over 4 reduces to
1 over 2x.
a half. And then yes, the x is reduced to that. So that's our answer.
So there is no remainder.
That is the remainder.
Well, we wrote our remainder as a fraction.
Oh, okay. I see.